For those of you that have not met me before, my name is Andrew Schultz. My current role here at SCE is the fun title of Manager of Design Engineering and SDS Implementation. Um, uh, it's kind of a neat little thing I get to say now because my main full-time focus is actually working on getting all of these tools implemented and run through engineering. But today, we're kind of here to talk about how we got here and what we've been doing as kind of a show and tell. So I'm going to go ahead and give you the brief introduction to how we got here, and then I'm going to throw it to my team to give you the ongoing nature of our PNC development as well as our P4A development. So at Edison, we're calling this the Intelligent Design and Construction Project. It's a little bit more than just the PNC and P4A implementation. It's integrating it with our enterprise systems and trying to develop a more BIM focused strategy going forward as a 15-year roadmap. Um, so the backstory on this IDC project, and again, if you've known me at all, or you've probably at least met me or seen me around, we've been working on this for 10 years now. This was first started between us and Automation Forces. Autodesk brought me out to the Duke office in Charlotte, and they showed me everything that they were doing with the physical for inventor stuff as well as the PNC stuff. And we have been doing kind of little projects off and on here ever since. We've had a whole bunch of starts and stops. We had some budget problems, but something about decommissioning a nuclear power plant. We had some various management turnovers, and some managers were like, "Hey, this is really cool stuff," and other managers were like, "I don't really see the benefits here." So, no. But we kind of never quit in the background. I was always encouraged to keep pushing forward and following through. We had regular contact with Autodesk and also the SBS folks, and keeping up with SDSIC and seeing all the other utilities and how they were progressing with things. So I never was short of information to bring back to people and different ways to try to keep pushing it forward. We got a little bit of a lucky break in that we use the distribution AUD system here at Edison, and they needed to do a refresh because their system was still based on the 2009 version of Autodesk, and it's 2018 I think at this point, and they're going like, "Hey, need to update this stuff." So we kind of got a chance to piggyback on their Vault implementation project as a way to pilot our work and do proof and concept. So ultimately, in 2021, we got funding to do our pilot, and we got training for everybody, and we went ahead and we embarked on it. And so this is what we call the roadway substation pilot. We call it roadway substation because that's the name of the actual substation that we borrowed the project from. So we had a 6 months time frame for our funding to do our training and proof of concept pilot work. This is a 115 kV line addition to a substation that was at the end of a bus, and it was isolated. It was kind of by itself. There wasn't anything in the position next to it. So we felt that it was a really good project to try to model because you didn't have it touching anything else. It would be kind of freestanding. The design was completed, but construction hadn't started on it yet. So another reason this was a good project to go ahead and do our pilot work on was we were gonna look at it and be like, hey, if we can catch any mistakes by modeling this all out, we can get it to the field as like a revision before they know. So we thought that that was another cool reason that we could do this particular project. All the parts modeling were done either internally by us, or we snagged a bunch of stuff off of Utility Content Hub. Um, not everything is necessarily the SCE specific equipment that we used. I think we used a couple of placeholder equipments, but it was basically like, hey, how can we make shift our own library to like really proof and concept that we can do this. So we built out this small library, and we went and did the project kind of like we did it by scratch, where you just have like an empty template, and you just brought in all your models to see how long it would take us to do it. So our findings for this, based on our pilot, we sat down and did everything and finished it all out and made some reproducible drawings. Is we actually found a 50% reduction in design time utilizing all this stuff. Um, with using the PNC tools, we found that we reduced wiring by 80%, but we had to increase the schematic time by about 20%, and that got us back to that 50% overall reduction. Um, Going through and trying to math out what that would actually mean for the overall life cycle of a project, we got to a number that we felt was pretty conservative, by saying that, on an actual project, utilizing these tools and seeing the cost savings over the design time, we would actually save about a third of the actual design time life cycle for a project, and that we would also see a significant number of change orders because your data would be more correct on all of the information. The other big thing for us is bill of materials. The way that we do things now, putting information into our ordering system takes a few weeks. It's a long and cumbersome process, but utilizing a data-driven approach with parts so that the tool itself can build a bill of material uh, got us down from weeks to hours and days to complete the bill of material system, even just inputting it manually. So after our pilot, we presented all of our findings to our upper management. We had an extremely enthusiastic reception to all of this. We got funding and also an accelerated timeline, and that's been a lot of fun to work through. We currently have a Vault implementation project going underway, and so what we decided to do while we were doing that was to really build out our block libraries as complete as possible, so that when we go to transition to our engineers and contractors using our software, it would be a much easier transition because all of your parts would be there. You just have to go through the library and be like, okay, I need X, I need Y, I need Z, and they go in the model, and I wire that all up, and now I'm done. And that's where we really were seeing our cost savings. So that's it for the introduction. I'm going to throw it to my team member, Chris Gatula, and he is going to present the PNC block library findings and project that we've got going on.
Andrew said when after the roadway project, we start the block creation for our PNC side. So for library for PNC, we start using the same structure on AutoCAD Electrical, but we place our library in the SharePoint. We kind of start creating our folders based on schematic, uh, wiring panel, and other reference drawings. The difference between the AutoCAD Electrical out of the box, we kind of separate the image folder in one location. So we mix schematic and wiring panels images in one folder. So it will be easy to manage it for us. Um, Also, we start the naming conventions for our PNC side based on um, recommendation by SPS and AutoCAD Electrical naming convention. We kind of like followed those naming convention. In the past, in our legacy drawings, we don't have uh, pretty much naming convention is just like numbering 1 to 100 or and more. And this will kind of help us with our blocks. Okay. And we also like separate our templates. We started using templates in our title blocks folders. Um, these are based on SharePoint, and to make it work in Article Electrical, we have to sync the SharePoint to our Windows folders, so it works just like a local drive. As soon as we have set up the our PNC side, we start using the attributes within our title blocks. In our legacy drawings, we pretty much use only a text, no attribute. It's just line and text. With the PNC tools, we start using the insert rev line attributes. We can implement that in this process. Moving forward, we start using the actual project to make all the blocks to see if everything works okay. To test it in an actual project. We base it on our legacy drawings. So visually, we try to minimize the impact within the other stakeholders, including the field. So we can like similar looks. We use our existing blocks. Our blocks is just like line and circles, no intelligent attributes in there. So we use that and start using the adding the attributes to that blocks. So with for other stakeholder will have minimal seeing that impact for them for the prints. One also things that we have new added in our during our design, it's the cable markers that we don't see in our drawings. For our designer and engineers, when they're using the Article Electrical, we start having to use the cable markers within within AutoCAD. So those are like additional works that we have to add in our design or for our designers. But for a printout purpose, for other stakeholders who's going to review a PDF portion or hard copy prints, we try to hide all those additions that we added for wiring purpose. So cable markers, we have other source and destinations. We can hide that, use a different layer for that, and hide to print. So not to print in the PDF. So they try to minimize the impact for other stakeholders. Also, during the pilot, we have projects that been reviewed with stakeholders. There's some thoughts that they don't want to see it. For example, the location, like the C9. So this is like based on the borders location where it goes to the other drawings. So they're not used to with seeing that in our drawings. So, but part of the pilot, we try to introduce that if gonna be like helpful for for the user, other stakeholders who's reading the prints. And so moving forward, we try to minimize that visually, but there's some exception that they understand that we have to use the tools, or they might see in the drawings. So during the process of conversion, we start uh, creating the manual, so it will be easier for us moving forward to to create the entire drafting manual. So I think it will be easier or minimize to revise it. So what we learned from the process during this pilot, and we just put it in the Bible. Also, we have continuous mentoring session with SBS during this process of the pilot. We If we have some difficulties how to make it works, uh, they were able to help us with the process. So far, we're still in the middle of the pilot, and there will be a room for more improvement. So time to time, we have to make some adjustment with our attributes blocks, just to accommodate the needs for our designers and engineers. With that, that's for our PNC portion. I'll pass it to Nico for our P4A process.
Hello, everyone. Nico Balagtas. I am the head of the physicals portion of Andrew's team, and today we'll be talking about our implementation of the P4A tools into our system. So the first thing that we have to do for the 3D modeling of the substation is, of course, to obtain our 3D models. Whenever we issue a traditional old unintelligent drawing for construction, part of that package actually includes the vendor provided drawings for our big apparatus equipment, such as circuit breakers, transformers, disconnect switches, you name it. Because of that, we our entire CDM, our library of this issued drawings is actually a repository of whatever equipment that we would want modeled is, and that was actually part of our approach to modeling some of our equipment. As you can kind of see over here in what I'm showing, the stuff on the left is the issued drawings for construction in our database that also contain a CAD file. We've provided those drawings to designers and modelers to create the 3D models that you see on the right to be able to be used in our P4A implementation. And that goes for a lot of the big materials that we have. Some of the materials that we have are like much smaller, such what we call B material items that are basically just like off the shelf or like provided by a supplier, and we were able to provide that information from either internal material specifications, or we contacted the vendor to obtain the drawings with which we modeled the 3D representations from them. So with all of that 3D modeling, the big transformers, the small materials, now we're ready to start designing our substations. But before we get there, let's get into the implementation of the entire system. When our objective for the 3D modeling is to essentially recreate the same processes and the same drawings that we get that we normally have, but with the addition, of course, of reducing human error, reducing repetitiveness, and increased intelligence in all of the models. Because one of the big advantages of the software is that every item within the model has data, has intelligence that they can then use in a big rule set, which is why connectivity is a big important thing for us. Nevertheless, when these drawings get to construction, they want some of the features to be isolated per feature. Sometimes they only want to see the foundations, the equipment, or maybe they don't want to see that and they only want to see the grounding and conduit. Then because of that, isolation of these features was important to our implementation of the software, which is a good thing that the tool allows for layer control, because naturally it's AutoCAD thing. So alongside the modeling of all of our 3D models, we've also assigned a layer to each equipment, such that if we want to see just the conduit stuff, we will turn on the conduit layer and turn everything else. Foundation, we want to see that. Foundation on, everything off, and so on and so forth. And it was great for us because then it allows us to recreate existing drawings that we already have, which I'm about to showcase right now. So if you can kind of see over here on the left is the general plot plan of the station, showing the overall layout and like all the connectivity. And you can kind of see there's a lot of data. Very impressive, very data dense. but also very hard to construct if you're trying to build everything else. So then we get to the isolation control, where I only want to see the grounding plan. So I only want to see a ground grid and all the connections. And in that sense, we only want to see the foundations and the ground grid and everything else. And you can kind of see layer control allows us to get rid of all the steel equipment, some of the bigger items that will get in the way, and only show the ground grid. Ditto for the conduit as well. In those kinds of drawings, you only want to see the foundations so that we can not see where we don't have to intercept, and then see the equipment that all these conduits attached to, such as the trench, the circuit breakers, and whatnot. And in that sense, we were able to isolate out the steel structures and only keep the stuff relevant to the conduit plan that you kind of see here on the left. And because of this layer control and how it's built into all of our parts, that they all have their own individual layers, we're able to recreate these things, our drawings of ease, and have no problem at all. With the added benefit that the existing model that we see up here still maintains intact. If we ever want to go back to this view, all we gotta do is unfreeze all the layers that we hid, and we can go back into our big super detailed model that everyone can see. So now that helps with the isolation of the features. What about isolation of the just the little areas themselves? And in that sense, that's where XClip comes into play. One of the things that the software allows us to do is we can create multiple different DWG files. They don't necessarily have to be within the P4A environment. But what we can do is we could reference the existing model, the one that we just showed earlier, and we could slice portions of that to show individual geographic sections of it. So let's say I only want to see the transformer bank. I can XClip just that, the 12 kV, I can XClip just that, and so on and so forth. And much like how it helps with, layer control helps with the isolation of features, XClip then allows you to show section and plan views of individual constructions. You can kind of see over here, this is the bottom is the traditional 2D unintelligent drawing of a 66 kV line position that we normally had. Above that is a 3D representation that we grabbed from the big model, and you can kind of see how it retains a lot of the features, and in a way is a little bit more of a realistic representation of how it looks like. And we were able to isolate all the other features that are in this drawing, as in we got rid of transformer, we got rid of the 12 kV, and only look at the 66 kV and make it look like a representative a drawing that we have in the bottom. Same goes for the 12 kV. It just disconnects the steel and whatnot, and only shows that section, which is great, because then it allows us to provide these drawings to the field if they ever have any problem with just this particular section, and call it a day. Naturally, to create like a physical design, you also alongside that need to have a physical a BOM of all the materials that we have, a bill of materials. Traditionally, like what Andrew mentioned, this process was a manual one, very prone to human error, and had a lot of repetitiveness, because not only do you have to manually draw the stuff in the drawings, you also have to at the same time create a separate unlinked bill of material that then references that drawing, which basically has a lot of layers of human error, because now I have two people making both things, one person checking them, and so on and so forth. This tool allows us to basically combine all of that entire process into one, because anything that we create in this model in here, like I said, has data attached. Part of that data includes the bill of materials that we have existing for the associated materials. You can kind of see over here, this shows the industry model parts catalog that we have, and on the left it shows like the naming convention that we have developed for each part, that's uniquely associated with just that component, as well as like the 3D model and all of the features of that model. And that's what allows us, so that if we ever install these parts in our model, the associated BOM also gets created. But more than just the bill of material, what this industry model allows us to do is to actually give some intelligence to the components by giving it actual data. And we've alongside just modeling your 3D components, within industry model, we've also assigned their physical features like their opacities, their weights per pound, and whatnot, so that we can develop rule sets and calculations automatically as we incorporate them into the software without having to do it separately, because the software does it all for us. Naturally, we want to make sure that that data is accurate, and because of that, we've referenced our existing material specifications that we have on hand and made sure that all the components that we made for this software comply with the data that's in there. I kind of highlighted the 1590 ACSR entries just as a kind of an example, but it goes a lot deeper than that for like our grounding and our conduit stuff. And then, of course, there's the formatting of the bill of material. The one on the right is the existing traditional like manual method that we have, and on the left is still a work in progress bill of material that we had for our roadway project, because the roadway was the one where we were able to incorporate the automatic bill of material. It's getting there, but as we add more components and add more focus into the formatting of the bill of material, it becomes a lot more robust. And I think it gives us some time to kind of show off the model. So I have the little model right here, just kind of showing off the presentation, but you can kind of see right there, it shows the ground grid, like an overview. And naturally, because it's a 3D model, you can pan around to see all the individual details that you can then naturally zoom in, or if you so choose, start to isolate, like just kind of show off the layer control a little bit. We'll just kind of freeze the layers of the conductors, and you can kind of see that now you can see everything but the conductors, allowing you to kind of see the features that you want to see more of for your design. The block library that we've developed the most of is naturally our connectors, because there's going to be a lot of connectors. What I showed you in the presentation was just like a snapshot, but you can kind of see here the model names, all of which that we've developed so that we can individually identify each item. And what's it called? And we've assigned some components to all of the to some of them, but the one that represents that best would be the conductors. There we go. So data such as like their tension and their cross-reference area, we've incorporated that into our template as well, so that in the future, once we've developed rule sets, we can then use all of this data to do more intelligent rule setting, and then design checking as we go along, so that we don't need to necessarily have to just look through it all the time. The data is built into the software, so that the software can actually just gather this, once you can throw it against some rules and determine if our design is good as well. And that's just for most of our how do I describe it, variable material. We also have some for the circuit breakers, and like we've had a lot of them. Circuit breakers, our transformers, our metering and whatnot. And all of these components is what allows us to build this 3D model that you see right in front of us. So yeah, and so far our progress is to our distribution stations, which means 66 kV and a 12 kV and above. Soon we're going to go into higher voltages, like the 115 to 220s and whatnot, and the software is only going to get more exciting as we go along.
For PNC library, so we have these are the schematic library that we have separated from the out of the box. So we have elementaries. We separate the all components, include the one lines blocks in here. So these are contains for the auxiliaries, part of the relays, separate for the individual blocks for the protection relays, the switches. Also, we had one lines. One lines are split between our switches and then the breakers blocks for schematic. Also, we had the wiring portion separated out of the box, because that might be useful in the future. We have the wiring portion, We have the relay, separate the relays for wiring diagram, and then we have some terminals separated in there, so it will be easier for the users. Yeah. So also we have the panel footprints. Each has all separated, easy to find for users, and easy to search for uh, for our designer and engineers.
All right. So the next thing that we want to try to talk about and show off is, so we've got all of these block library and implementation stuff kind of done. And so how are we going to transition this to our engineers and contractors? We want them to kind of follow a more defined workflow. So I'm going to throw it to JP, and we're going to talk about the technical manuals that we're producing.
Thanks, Andrew. Morning, everyone. Name is JP Javier. Like Chris, I work under Andrew Schultz in the SDS implementation for our substation project. So what I'm going to show you guys is our working progress uh, technical manual. And we have been working on this for, I would say, the past couple of months. And basically, what the manual is today is, well, in the future, we were actually planning to not only replace our current drafting manual, but also incorporate a manual for our STS tools. So we started with developing the section for our, for the PNC side of the house. So can you guys see my screen? And I'm going to just kind of scroll through while we make this a little bigger for everybody's sake. I can't. Where's the zoom? Oh, there it is. Okay, you guys see this okay? So we're just kind of calling it today
Yeah.
as the thanks Armand, intelligent substation design technical manual. It may be called a different thing in the future, but so we have here some so we have the intro portion, and what we focus on today is actually to develop uh, two or three sections here. So the first section is section 3, which is basically synchronizing with the SharePoint side. So the reason, a little backstory on that, is the reason why we have our stuff in the SharePoint site is because we don't have our Vault system up and running yet. And SharePoint was I guess, the winning candidate for as a placeholder or a temporary tool or temporary storage that works with what we need for PNC. Um, so in here we developed a section on how to actually access it, even get, how to gain access to the SharePoint side, do the IT request and stuff like that. So I'm gonna flash you guys the quick view of what that SharePoint side looks like on our side. So basically we have a few sections in here. We have our prime contractors. In here we have basically the contractors can save their projects in here and use these as their repository. But the main thing is to actually house these blocks that Chris and Nico were showing earlier. So the first one is the PNC library. So I think you've seen this screen from Chris earlier. He has this synchronized in his laptop. I have it synchronized on mine as well. And so with this feature, it kind of mimics the Vault functionality of actually downloading the files in your system, and your program sees these locally, and we just had to do some configuration so the software knows to look at those locations. So similarly, we do have the counterpart, the P4A library. So in here we have our blocks and our templates, our styles, and all those other things. So to be able to connect to these, we actually put that in this technical manual. And like I said, this is including how to get in the SE system, submit the IT request, and so on and so forth. So this is like a um, detailed steps on how to do that. Okay, and then the next part of the manual is we actually have, we have some settings that we needed to configure for the software to work. So we have those steps in here as well. So we kind of test drove this with a couple of our newer users, and it's we're still making tweaks until today, but this is pretty much 90% done in my opinion. Same thing here. We're syncing, the libraries and like very detailed steps here.
Like one of the things that we recommend is, there's a lot of, technical settings and, like configuration and stuff like that with our products, right? And so especially working with contractors and making sure that everybody's on the same page, it's really, really important to have things documented and to do documentation like this, along the way as you guys are developing, with our products. So I just really want to reemphasize the importance of doing stuff like this. I also just had a quick curiosity question on the SharePoint. Are you guys versioning in SharePoint too, and using like the check-in, check-out feature of SharePoint?
So short answer to that is no. The reason being is the libraries are only read only for everybody else, so nobody really touches those.
Oh, okay.
So these blocks here, they're read only for everybody except for me, Chris, and Seb. Which
Oh, okay. Okay.
yeah, we
Perfect.
are the ones developing the content, so it's read only for everybody. We actually did use the check-in check-out system with our in-house projects, and the reason being is SharePoint doesn't, like, unlike Vault, doesn't have the capability of tracking which drawings were checked out, or when you open it up, it has the hey, do you want to check out this file here so you can work on it. So what we did for that is, if let's say, let me see, so for example, this part here, Chris is working on this project here. So what we did was, to prevent overwriting or accidentally creating a separate file, we before you
Yeah.
start on the project or on the drawing, you actually check out the file. So then when you go back to your system, somebody else opens it, it prompts them, hey, this file is checked out to Chris or to Mark, so you can attach it. So
Okay.
that's kind of how we maintain control of that through SharePoint.
So you guys are doing it like on your project drawings, but just not on your library symbols and stuff.
Yes,
Oh,
because
okay. All
the
right.
libraries are only read only for everybody who's using it.
Okay, gotcha. And
Which
has the checkout check-in been working well for you guys? Have you guys ran into issues besides the fact that it's not integrated with AutoCAD like Vault is?
um the only issue is, let's say it's checkout to Chris or to Mark, that nobody else can, like, even if Chris saves it and closes it for the day, nobody else can get in the files. Like, they can open it read only, but nobody can make modifications. So what Chris needs to do is to actually go here and check in the file, um, for somebody else can you know get to it. So it's not like an automatic check in check out like Bolt does, where if you save the file, it automatically checks it back in. You would have to physically go in the SharePoint site and do that.
Gotcha. Okay.
So it's
Cool.
like
Thank
just
you.
an extra step,
Yeah.
to account for. Um, but yeah, it's Chris, it's kind of worked so far, right? Nobody has made duplicates
No,
or
I think we're good.
overwrote the file. I We opened this feature to our external contractors, but some of them have the vault in their system, so really they didn't see a need to use this system. But yeah, it's also open, for them to use this feature. Okay. Any other questions? Should I continue? Okay.
No,
Let
yeah,
me-
go for it. Go for it.
Okay.
No, thanks, JP. Yeah,
Yeah,
keep
no
going.
worries. So yeah, let me go back to the manual. So this is like basic PNC configuration, how to set up a project. Chris had created this project template. So all you do is, you just copy the project template if you start a new project. And oh wait, this is like configuration still. As you can see, we have snapshots as well. So we have these little arrows pointing to which button to press, that kind of cool stuff. So this is really meant for users who are brand new to PNC or even AutoCAD electrical, but will probably need some AutoCAD experience so they understand how the ribbon works and all this stuff. Yeah, it shows the process, how to copy, and which attributes they need to fill up. Just like mandatory attributes that are needed. It explains which like there's a portion area. Some of our older drawings use a different scale, so it even explains how you modify the template or the title block, stuff like that. Let me see real quick. Yeah, gonna go a little faster. Apologize. Okay, so we get to the point where, hey, you have a brownfield project. How do you go about doing PNC? So this is, we have enlisted here the steps. Hey, first thing you do is get all your legacy drawings. And then what do you do next? So there's step one. Get template. Okay, we also have a section here for non-CAD legacy drawings. We still have a lot of raster drawings in our system that we still use because we haven't, had the time to convert everything to CAD. So we have those steps here. We have I think we have we have a microstation drawing section here as well. Right here. So we have a few microstation drawings. So, need them converted as well. So once you go through those steps, we discussed briefly how you do your PNC design. So there, these are the menus that Chris was showing earlier as well. Yeah, these ones I think we're still working on these sections here. And then, after your elementaries, we go to your rack elevation drawing. So there's steps, slightly different menus, different sections of the blocks, so on and so forth, until I think this is where we have stopped. And and then we have the greenfield design, which should be somewhat similar to brownfield, which we haven't, gone through yet. So that's kind of what the progress is for our, we're calling our intelligent substation design technical manual, but we're focusing today on the PNC side of the house. And like I said, mentioned earlier, we were hoping to integrate our drafting manual in this manual as well. So, it's like one stop for substation design.